Hello, everybody, and welcome to what's going to be the start of a new series. I did a video on the Soyuz abort, which occurred a little bit ago now, and then I also just did the bear sheet mission, and I was thinking to myself, hey, this is quite fun, actually. So I'm going to start a new series in which I recreate real-world missions here in a single save of Kerbal Space Program. Now, as the world moves on and Kerbal Space Program continues to get updates, we'll get new versions of Kerbal Space Program that comes out. However, I really want all of the missions here in this one save. That way we can look back and say, oh look, here's the Bearsheet lander. Oh look, here's um, this satellite that was placed in geostationary orbit, or here's a Dragon capsule, or whatever it may be. So we're not really going to go retro, or I should say, we are not going to go retroactively back to get any missions that have already previously occurred. We're going to start from today, and I'm going to try to get every mission. I may miss one, or if it's very routine mission or something, in like just some CubeSats or something, I might not be doing the Electron missions, for example. But we're definitely going to hit the major ones. So that starts with a lot of the missions that occur now are to the International Space Station, and so that means we need an International Space Station to go to. Um, Also, that being said, as far as retro missions, I will be docking all of the Progress resupply capsule and the Soyuz capsules that are currently docked to the station, and we'll have crew on there, and we'll do crew rotations here in this one Kerbal Space Program save. We'll do everything. Um, Also, this Kerbal Space Program gets updated. We're going to stay in this version. So this is Kerbal Space Program 1.7. 1.7.1.0 is the current um, save, or the current version of the game, and that's what we're going to just stay in as long as this series continues to go. So there won't be regular uploads after we get the station up and stocked. It's just going to be, oh, there was a launch, and so we'll do that, and we'll probably get that uploaded and just fit that in with the upload schedule. So what we're doing right now, so that's talking about what's going to be coming. Now let's talk about what we're doing. This is the first launch of the building of the space station. So we just had first stage burnout and cutoff, stage separation, and second stage ignition. So this is a two-stage rocket with a upper stage, kind of like the Fregat upper stage that the ESA uses, which was designed to be an interstellar probe, but they use it for an upper stage because they can reignite the engine multiple times. And it works really well for placing things in very precise orbits. So we had first stage cutoff, separation. Second stage is now ignited and burning. Um, the station is going to orbit at approximately 250 kilometers, 250,000 kilometers above the surface of Kerbin, as the real International Space Station orbits about 250 miles above the Earth. I figured that would be um, a pretty good orbit to go into. So we're going to head straight to that orbit with this first launch because it's the first piece and nothing else is up there. The next launches, and when we go to do rendezvous, we're going to aim for an orbit about 150,000 kilometers. And then we'll get into a good inclination, and then we'll raise our orbit up to the 250,000 kilometers that the station's at. So in this first stage, we'll see it here after stage separation in just a little bit, or after the fairing opens, sorry, in just a little bit. About 80,000 kilometers, we should see that. 80,000 meters, sorry, we should see that. There it is. It's going to be really dark here on YouTube because YouTube seems to darken videos. But we've got 4 truss sections, and we have 2 of the Gigantor solar panels on each of the 2 sections. And so we got 4 of those total, plus 2 radiators to dissipate heat. So we're just checking our inclination, getting our maneuver nodes set up here. All of these missions will have commentary. And yeah, I was gonna say I'm gonna make these videos have their own um, playlist, but I don't think so. I'm just gonna put all these videos in my standard Kerbal Space Program playlist. Now, I didn't think about placing solar panels since I was launching giant solar panels. I didn't think about putting solar panels on that upper stage, so we almost ran out of power there. Um, but we put our probe core into hibernation mode, and we'll be all right. So I talked about the upgrades to 1.7 a little bit, but I absolutely love, if you're new to Kerbal Space Program or not super familiar with how orbital mechanics work, if you look over on the left, you get a bunch of flight data. So, uh, working from our top down, we have stage 0, which is just a separation, stage 1, and it will show you that it has, or action 1, and then they count up from there in Kerbal Space Program. So we have 2,098 meters per second of delta V in that stage. The stage we're currently using has 1,178 meters a second delta V remaining in it. Lots of good information. So if you're curious at what's going on or exactly why we're doing a burn in a certain place, if you look over to the left, lower left, it will show you a lot of information, and the information you're looking for will probably be there. Right now, we have an apoapsis of 279,000 kilometers, which is a little higher than we wanted. We was aiming for 250,000, but here we are. And we have a periapsis of negative 207,000 kilometers, and that's because we're not in a circular orbit yet. So we're going to be performing our circularization burn here. Another thing we're going to be careful with is leaving space debris. Since this file is going to get very large as we continue to add real-world missions, we want to keep our space debris as low as possible. So you'll see here after we finish the circularization burn right there, that we have a periapsis of only 32,000 kilometers. And we have stage separation, and there goes that, I'm not sure what we would call that, our frigate upper stage, I guess you could just call it. We do some testing on the frigate upper stage at the end of this mission also. So because we separated that upper stage right there, the second stage, it will burn up in the atmosphere. None of that, all that whole stage will burn up because at 31,000 kilometers, the atmospheric heating won't let it stay in orbit, and it will explode and burn up on re-entry. So and we're just pointing back prograde again, letting those reaction wheels do their job, because we're in the same orbit as that upper stage. If we didn't do anything, we would also burn up, and we don't want to do that. So all we're doing right now is the orbit raising burn. Going to raise our periapsis. You can see it climbing now, passing 150,000 kilometers now. Still going, and there we go. 250,718 kilometers above the surface of Kerbin. And now our apoapsis is too high. We're at 292,000, so we're going to do another burn to bring that down. Now I had to extend 2 of these panels. I didn't want to, but I had to extend these panels because of our electricity problem. In a future design of this upper stage, we're going to fix that. I tried to model the orbit of the International Space Station as closely as I could, put it on a little bit of an inclination there. So it will matter as we go to do resupply missions and whatnot. We'll have to wait for good intercepts. So and now if you look at the bottom left again, we're just adjusting our orbit, trying to get close to 250,000 kilometers apoapsis and periapsis as we can. Try to get a really nice circular orbit. It makes it a lot easier for the next missions that we do to add to the station. If you're in an elliptical orbit, it makes it hard to intercept. If you're in a nice circular orbit, it makes those intercepts a lot easier. So we bring that right down, real close, just within a couple hundred kilometers from the highest point to the lowest point. Then, of course, we need to get ready for this maneuver, so we're going to let those reaction control wheels work and point out. Warp that maneuver. So we have an estimated burn time for this maneuver of 3 seconds, which means we're going to want to ignite our engine, retract the solar panels so we don't damage them. We're going to want to ignite those engines at about 1.5 seconds before that node. That way you burn half the burn before and half the burn after, which will get you a good. So Kerbal Space Program really doesn't do half seconds, so we do our best. And That was a pretty good burn right there. Apoapsis of 251,000 and periapsis of 250,000. That's pretty good margin there. Extend everything. Now there's no batteries out here on this truss section, so once we decouple, it won't have any power, but the batteries will be coming with the rest of the station. So again, we're going to decouple that node, leaving absolutely no space debris behind. And now we just need to wait until we get some separation between us and the truss. Put our computer back to hibernation mode so we don't use all of our electricity. Future versions of this upper stage will feature RCS thrusters so we can more readily maneuver away from this station. And there we go. Got some separation now between us and the station. We're no longer at risk of crashing into it. So we're going to point retrograde and begin our deorbit burn. Now we're curious here, and I'm going to run an experiment on this frigate upper stage because I want to know if it has the ability to be in orbit at the station and burn its engine the opposite direction and then get into an orbit retrograde to the station. Just because there's quite a bit of delta V up here on this stage, and frankly I'm just curious to see if it will work. So we're going to try that right now and see what happens. You can track the progress of this experiment. If you look at the bottom left of the screen, you see the apoapsis lowering just a little bit, which is good because we don't want to accidentally run back into our station. And our periapsis is continuing to increase because we're slowing down, and so we're going to be coming back and hitting the Earth at a steeper and steeper angle. But what we're trying to do is we're trying to cancel out all of our orbital velocity in one direction, and I clicked the wrong button. Yeah, that's okay. Well, if we get really close, we know that we kind of messed up there. If we continue to have our reaction control wheels point towards retrograde, then it will just spin around and start spinning faster and faster. We have to hold our attitude so that once we start going the other way, we can start accelerating the other direction. I know I got sidetracked. We'll be coming back into Earth at a steeper and steeper angle. Our orbital speed right now is only 800 meters a second, which is very slow for spacecraft in orbit. Let's see. We should make it. I don't know if we'll be able to get back in orbit the other direction, but we'll definitely head back the other way. 600 meters a second, 650. Getting close to basically a standstill in orbit, but we're getting close to start heading back the other direction. 400 meters a second. As soon as we start accelerating again, we'll know that we have done it. And we've done it. We have successfully changed our orbital direction. It's a lot of fuel to do that. With only 1,400 meters a second, though, I don't think that we will have enough delta V to put ourselves back into orbit the other direction, but let's see. If we tried really hard, we could. If we did some fancy maneuvering, we could definitely get in orbit, but just burning this way, I want to see what happens. This is essentially like a boost back burn that the SpaceX Falcon Heavy performs to land back at Cape Canaveral. That's what their first stage boosters do when they're landing at the landing pad. So very impressive that they're able to do that. Our delta V is down to 500 meters a second. Periapsis is at negative 440,000 kilometers. So yeah, definitely not going to make it, but pretty cool. A lot of fuel there. This upper stage is very capable. I really like this upper stage. We're definitely going to use it for a lot of our station building that we do. And there we go. Apoapsis of 252,000 kilometers. Now that's actually pretty scary because that takes us up above the height of the station. Luckily for us, we're crashing to the ground before that happens. So thanks for watching, and we'll see you next time.